Okay, so earlier we did a video on an overview of the basic trigonometric functions. So today we're going to do an example of how these are used to figure out angles. Okay, so in an earlier video I said that the sine of theta, that's how we abbreviate sine of theta as in sin and then the Greek letter theta, is equal to the opposite divided by the adjacent, or the opposite over the hypotenuse. So we simply write them as a ratio. So this is a right triangle. These three sides would form a right triangle. Okay, so we have the opposite is 12 divided by 13, and that's the sine of theta. Okay. And there are ways to actually figure out what theta is, but we're not going to go into those today. And then the adjacent is 5, the adjacent, and then divided by the hypotenuse, 13. So the cosine of theta would be 5/13. Okay? And then we have the tangent of theta, which is the opposite over the adjacent. Okay? So 12/5. Also in an earlier video I mentioned that there's a relationship with the tangent theta, the sine theta, and the cosine theta, and that relationship is this. The tangent of theta equals the sine of theta divided by the cosine of theta. Okay? So I'm going to show that to you now using these numbers. So if this is true, I should get sine of theta divided by cosine of theta equals 12/5, if this is true. So we have this. So the sine of theta is 12/13 divided by 5/13. Okay, with division of fractions, it simply says to flip the second fraction. Okay, and what happens? 13s cancel out, and so you have 12/5. Which is, again, is what we should have gotten the tangent of theta. So that just shows, so that's what we call an identity. Okay, what we call in trigonometry an identity. That tangent theta equals sine theta over cosine theta. So again, that's a quick example of how we use these different ratios to figure out angles.